All right, welcome to week 3. Hopefully this week you are able to adjust a little bit more to the online format with all of your classes. Again, feel free to reach out to your teachers if you have any questions or are confused on something. Just let us know. You can always reach out to me. This week we will not have a scheduled Google Hangout session time, but if you have questions, email me. We can set up a Google Hangout time if we need to as well. So what we are getting into today and on Wednesday will be solving systems of equations. So you practiced that back in week 1. So we're going back to that, but now we're also solving them using matrices. Okay, so last week you practiced a little bit of what does a matrix look like, how do I add them, multiply numbers by them, and then multiply matrices together as well. So that will come back into play a little bit as we get into solving systems with matrices. This section we're going to break up into 2 parts. So today will mainly just be some vocab stuff and understanding how to connect matrices and systems of equations. So it'll be more notes, but then Wednesday you'll get more practice problems with the solving and row operations. So here are our first set of notes. Vocab is Gaussian elimination. Okay, so that was a famous mathematician that this is named after, is used to transform a system of equations into a triangular form. So if we look at here this equation, you have a system of equations, and we want to get it into a triangular form, meaning that our last equation is one variable equal to a number. Your second to last equation is going to be 2 variables equal to a number, and then your third equation, or your very first equation, is going to be all 3 variables that you have equal to a number. Okay, and that kind of forms a triangle here. So our goal then is to get it in this format, and that makes it really easy because once you have a value for one variable, like this z equals 3, you would plug that value into z here and solve for y. Okay, and then you're going to plug that same value back into z in the top. You're going to work kind of from the bottom to the top with this. You would solve for y in this equation, and then whatever number you get, plug it into y for that equation there, and then you can solve for x. So this is kind of like when we use that graphic organizer. We got one variable first, plugged it back into the equation with 2 variables, and then plugged it back into an equation with 3 variables. Same type of format, but we are going to focus on this triangular form, especially as we move into connecting those to matrices. An augmented matrix is a matrix that's used to represent a system of linear equations. Okay, we always typically start with your variables in alphabetical order. So here we just have x and y. When you write it as a matrix, you don't have any variables. A matrix is just numbers. So you put whatever number goes in front of the variable. So for this first equation, you have a 2 and a negative 3. So that's going to go for your top row in a matrix, 2 and a negative 3. Your second equation, you just have a 1 and a positive 4. So that goes in for your second line. Then notice here that we have this vertical line that kind of separates our second column from our third column. That's kind of where we would write our equal sign. So notice too in our matrix, we don't have an equal sign. So that vertical line is representing our equal sign, and then opposite of that will go whatever your equation is equal to. If you do not have a variable that's represented, let's say we just have this example here, minus 4y. Okay, so 2 and negative 3. We have that break for your equal sign, 8. You do not have a value for x, so if you don't have a value for x, there is 0. You need to make sure that every little spot has a value that's placed in it. So 0, 4, negative 7. Okay, so that will come into play as we start to work with matrices a little bit. So Gaussian elimination is a way where we're going to try to get these down to triangular form. So your very last row of the equation or matrix is just one variable, and then you build up as you work up the triangle. An augmented matrix, it's all numbers. that you take from a system of equations. So row operation on an augmented matrix is any of the following. You can switch two rows around. You can multiply a row by a constant. You can add one row to another and then replace one of those rows. Okay, row operation is very similar to what we would do with a system of equations. The main difference here is going to be the idea of switching two rows around. And that's just kind of to reorder it, to make it look a little bit nicer if you wanted. Row echelon. Okay, so row echelon form is you're using row operations. So you're multiplying it by a number, you're adding rows together to obtain a triangulation of the matrix. Okay, so if we go back to that Gaussian elimination, you were trying to get it into triangular form. So once you have attained triangulation of the matrix, you do that with row echelon form, then it is in reduced row echelon form. Okay, and the goal here, that if this row would be X, this row would be Y, this row would be Z, and then we don't include it for this one, but this would be whatever it's equal to a number. Okay, if you look at this format and you were to write this as an equation, you have X equals 6, Y equals -2, and Z equals 3. Our goal is to get the ones on diagonals so that we know exactly what your variable is equal to, exactly what number it's equal to. Okay, so there are a lot of different vocab stuff in here. I would make sure that you guys write this down and write some of the examples down. Again, this lesson is going to be very heavy on the vocab in the notes, and we will start to apply those a little bit today and a little bit more than on Wednesday. So reduced row echelon form is what's written here. Okay, row echelon form would just be, let's say we had 1, 2, 3, okay, so this would be row echelon form, and this one here would be reduced row echelon form. Okay, so row echelon form it's still in the triangle. Okay, you have Z, then you go Y, X as you work your way from the bottom row to the top. But you have all these extra numbers. You don't just have ones on the diagonal, then zeros. Reduced row echelon form has 1 on diagonals and then 0 everywhere else. Okay, so let's look at a few practice problems. For these two, we are just going to write the augmented matrix. Okay, so we're not doing anything with reducing it or anything with changing. We're just plugging in these numbers into a matrix. So I know that I need to have 7 and 16 on the opposite of this vertical dash. And I have 5, 4, and 4, -2. That's it for this problem. For B, we now have 3 variables and 3 equations. So I need now a 3 by 4 matrix. I'm going to do my equal sign part first, 9, 2, 8. Then I'm going to write the numbers as I go across. I have 1, 3, -2. 2, I don't have a y in this second equation, so that gets 0, -6. I don't have an x in my third equation, so it's 0, 2, -2. That's your augmented matrix. Okay, so that should be pretty self-explanatory so far. Now we are going to write the system of linear equations represented by the augmented matrix using variables x, y, and z. Notice that sometimes we have that vertical dash, sometimes we don't. If you want to put that in, I typically will put that in just so that I can see where my equal sign is. It's always that last column in a matrix. Okay, and then we have all 3 variables, x, y, and z. So we're just going to label these across the top. Okay, that just kind of helps me. And all I'm doing is writing it as a system of equations. So I have 1x plus 1y minus 1z equals 2. 3x, -2y, 0 equals 2. And then 5x, 3y, minus 1z equals 1. Okay, so all I'm doing is pulling these numbers in and putting them in front of the variables. Another trick that you could do is if you know this first column is x, just go ahead and write x all the way down that column. And then do so with the y and the z. And then you can pull that out and write it as an actual equation if that's easier for you. Okay, if you're feeling confident with this, go ahead and pause it and you can try the second example. Same type of thing again. We have an augmented matrix. So I'm going to put that dashed line there. I have x, y, z equals a number. So I'm going to go ahead and label my first column as x, then y, and then z. And then I need to write my equations. 1x plus 1y plus 1z equals 6. 1x minus 2y, 0z, I don't need to include that, equals 9. 0x, I don't need to include that. 3y plus 4z equals 6. And that's your system of equations. That's it. Okay, so I don't want you guys to forget all the vocab stuff because we will come back to that, especially the row echelon form and reduced row echelon form as we get into solving matrices using systems of equations, or solving systems of equations using matrices. But for right now, on your homework, you will see, I believe it's questions 1 through 13. I just want you to do problems 1 through 3 and problems 8 through 9. 1 through 3, you're writing an augmented matrix, so very similar to what we did for this slide here. So pulling a system of equations and putting those numbers in a matrix form. And then questions 8 and 9, you're going to write a system of equations. So like we did for this slide, you'll be given a matrix. You have to write a system of equation. And then you also need to determine if it's consistent or inconsistent. Consistent means that it has a solution. So either your matrix gives you a true statement or is solvable for a value. Inconsistent means that there's no solution. Okay, so that typically happens when you have 3 equals a negative 4, or you have a false statement. Okay, so go ahead and practice this. I will try to post that second part a little bit earlier on in the week. If you are the person who typically does your work pretty early, then you can get started. But make sure that you're understanding connecting matrices and systems of equations, especially as we get into solving them later on this week. All right, you will hear from me then, hopefully by Wednesday.